Right, here we'll use a comparison test to determine whether this integral converges or diverges. If it converges, we're not going to find the actual value. We just want to know, does it converge or does it diverge? Now, the way I like to think about the comparison tests is this first one says if you're smaller than convergent, then you're convergent. And this one here says if you're bigger than divergent, then you're divergent. Oops. So now think about just the thing under, I think they call it the integrand, right? So 1 over the square root of x cubed plus 1, this is smaller than 1 over the square root of x cubed, which is equal to 1 over x to the 3 halves. Now when we put an integral symbol around this with the dx, right, this will be a p integral. Here p is equal to 3 halves, which is bigger than 1, so it's convergent. And so then we can use this first comparison test. This is my g of x. This will be my f of x in the test there. And so smaller, this one, g of x, is smaller than something that converges, so g of x converges. Not g of x itself, right? It's that we're not talking about the convergence or divergence of g of x itself. We're talking about the convergence or divergence of the improper integral of g of x. We're going to compare that to another improper integral. Now, let's talk about a little intuition for why we should think, why this? Why 1 over the square root of x cubed plus 1 is smaller than 1 over the square root of x cubed. So you can think of it as you're dividing by more, right? If 1/10 is less than 1/9, right? You're dividing 1/10 by, you're dividing 1 by more, 10, so it's going to be smaller. So this one here, right, you're dividing by more. You're dividing by this little bit more, the 1. You're not dividing by 1 more because there's the square root and all this sort of thing, but it's still, there's more there, right? So you're dividing by more in that case, and so it's smaller. Excuse me. Now, a way to be sure is to do what I'll do now. Okay. X cubed is less than x cubed plus 1, right? Here you're adding 1, right? So x cubed is less than x cubed plus 1. Now, taking square roots doesn't change the sign. This is because the square root is strictly increasing. The square root function is strictly increasing. And so then we can say this tells us that the square root of x cubed is less than the square root of x cubed plus 1. And now we'll use this rule that says that if a is less than b, and a and b have to be positive for this to work. So a, b are greater than 0. Okay, so we assume that if a and b are greater than 0, and in this case we're assuming that, right, because our bounds are 1 to infinity, so we're greater than or equal to 1, so therefore we're greater than or equal to 0. So therefore we're greater than 0. Okay, but what the rule says is if a is less than b, where a and b are both positive, this tells us that 1 over b is less than 1 over a. So that's the little rule that I'll use here. So this is like my a here, and this is like my b here, right? So then we know that 1 over the square root of x cubed plus 1 is less than 1 over the square root of x cubed. And you can even take this a little further and put the integral symbols in there. You have 1 over we know that this converges, p equals 3/2. This converges, so smaller than convergent is convergent, so it converges.